Okay, here's our first ALEKS example. Actually, on this video, I just tried to include all the problems dealing with probability distributions in terms of the generic term, and also the ones related to it with expected value. All right, so all we need to do here is for this particular one, again, basic idea. Characteristics of a probability is that all these probabilities have to add up to one, and they cannot take on a value that's outside the range of 0 and 1. And so what we need to do is, there's not one unique solution for these. You have a lot of different combinations, but the combinations have to have that characteristic to um, essentially satisfy the requirements in order for it to be a probability distribution. So to start these out, you just, again, you're going to figure out, well, okay, all these add up to 0.59. And so I have to have some combination here to get two numbers to make the total sum be add up to one. And so what we'll do in this case here again is just, since that is 59%, probably the easiest way to do this makes it a nice, easy number. If I type it in there, 0.01, that makes it 60, and therefore I can make this one 0.40. Okay. So, I'm just going to go ahead and check this just to show you. And, I don't know what's going to happen here if I press this solve button, but it might switch these around. Let's just see if we get two other numbers that add up to. No, it's not going to do that. Okay. But anyway, so there are a lot of different combinations. This could have been 0.02 and 0.39, and you get the idea there. All right. Moving on to the next type of problem here is you might be given some sort of, word problem here. And so here, this one kind of seems really confusing to start off with because you've got X's and N's and so forth. And what this equation for X is it's explained here. And essentially, I don't want to get too far into it, but basically what they're going to do is N be the random variable that counts the number of even rolls. Okay. And so what you'll do is you'll determine X. N is going to obviously be 0, 1, and 2 or 3. And so you're going to get some values that correspond with those numbers. And if I plug them in, I'm going to get -4, -2, -10. And so what we'll do here is essentially just, go through and, look at each of these outcomes here and determine the probability of observing those. All right. So we see that we have three values of X here, right? We could take on -4, -2, and -10. That's it. So what I'm going to do is I'm going to type those in because this is the probability distribution we're filling in right here. Okay. So again, don't get bogged down into what the ends are in this equation. It's just kind of explaining where these numbers come from here. Okay. And so I'm just going to go ahead and type those numbers in. Now, obviously, we have essentially 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. All right. And so probabilities is just going to be a matter of counting, like probability in classic probability theory. We always do. So I'm going to just go ahead and fill these parts in here quickly. And I don't know if that's quickly, but they're filled in. Okay. And now, so out of the 8 possible outcomes, how many of them are -2? Well, it looks to me like we have 1, 2, 3 here for -2. So I'm just going to put a 3 in there. As far as -4 is concerned, it looks like we have 1, 2, 3, 4 of those. All right. So I'll put the 4 in. And there's only one way to get to -10. Okay. And so there you have it. Now I can quickly add these up, right? If I'm adding up 8s, I got 3, 4, and 1/8. They all add up to 8/8. So, you could just, that's kind of like a double check there to make sure you did it, you didn't miscount. If you make a mistake, it's going to be because you miscounted, which I'm not going to say that's easy not to do. It happens sometimes. All right, so I'm going to go ahead and check this just to verify. And yes, indeed, we did that correctly. Okay, so you have to use this equation palette here to get your probability expressed, but nonetheless, this does seem to be really confusing when you introduce this n and you're wondering what's going on here. But again, all that's doing is describing where these numbers are coming from. All right, so there's a word type problem. If we get into the expectation and variance of a random value, here we're going to, again, go ahead and do this. There's a couple different ways. If you look at my video, I explain how to do this in the software that I mentioned earlier, which is probably the easiest way. You can result on these formula or use the result of these formulas here in a calculator, which, that's again going to be up to you. If I find those down here, it should be somewhere around, I believe. There it is. Okay, so essentially what we need to do is multiply each of these values of the random variable times the associated probability. So you find that here. Here we're going to, again, calculate the variance. This is a formula for variance. There was another one that was given in the example, alternate form of this also. But this, again, is one, once you actually have to go through and take the expected value of x squared, okay? And so what you're going to do, again, is multiply the probability of the x's by that value, and I'll show you here real quickly how that's being used, okay, in the explanation. All right, but before I do that, I would just want to show you that this is pretty easily done if you use the software here. So let's see, we're going to start from negative 1, 0, 1, 2, 3. That's pretty simple to remember. Watch out, forget it. So let me come over to here just to get this over on the end. Okay, so if I go back over here and I am going to get out here of this and I take a look at discrete random variables, okay, in terms of probability. And I already forgot, so let me go back, negative 1, okay, up to 3, right? Okay, all right, so I go negative 1, 0, and you're saying, well, what do I do here? Well, we're just going to keep adding these 1, 2, and 3. Okay, so I put the values of the random variable there, and then I'm going to put the associated probabilities. So if I try to slide this over so I can look at both of these at the same time, might be helpful. Okay, there we go. Okay, so I'm going to put in a 0.3 here, 0.05, 0.25, 0.05, and 0.35. Okay. So there we go. And I'll just hit begin analysis, and there you have your mean and standard deviation. So real easy to type those in, 1.1. And also 1.64. Okay. Now, I'm just going to go ahead and check this just to show you, verify that that did in fact work. Let's see, B, my answer is incorrect. What did I do here? Okay. Oh, it wants the variance. I'm sorry, I put the standard deviation in. Excuse me, I got to pay attention here. So I'm just going to take on the calculator here and type in 1.64 squared. I can read the directions right there. Sorry about that. Okay, so I take that and I am going to go ahead. Where's my squared button here? It's got to be somewhere. Oh, here we go. Squared, and so I get 2. Try that again. So I get, let's see, does it say to round? It doesn't say to round, so I'm going to type all those in 2.6 6896. Okay, so I think I copied that incorrectly. 6896. I'll recheck that. Okay, there we go. Okay, so yeah, I just looked at the standard deviation. Sorry about that. So, okay, so you see how I did that. Um, here's the explanation. And like I said, if you want to, here are the formulas here and how they're used, how we go ahead and calculate all those values here for the variance and the um, standard deviation. Okay, so here they are using this particular formula. I'm not going to go through all the details of it, but here's the expected value, taking each of the probabilities times the associated random variables to get 1.1, and then so on. Okay, so you can see that, that's how that's done. Okay. They had 2.69. There must have been some sort of rounding that went on there. I didn't type all that out on the calculator, but anyway, there you have it. Okay. So if I go back to the question there, again, and I press the solve button, I guess they rounded to 2 decimal places. I did not. So anyway, there you have it. That's how you do this one here, and that's expectation and variance. Okay, so another, again, phrase for that is the mean. Okay. As far as the other problems here, let me just go ahead and take a quick, there's one here we already did, introduction to expectation here, counting, here's a business, let's do this one here, business application, can't do all of them, but all right. And so what we're going to do here, and I'm just going to kind of go over this one here, just so it's pretty simple. Obviously, it's just trying to put all this into perspective. But here we have this offering a 2-year limited warranty for $934 on all new cars. And the terms of the warranty would be that they would replace the car free of charge under certain specified conditions. So it's costing them $12,100 to replace this. And there's an 8% chance that would happen, and a 92% chance. So we only got 2 probabilities here. And so what they want here again is, it says if knows it'll sell many of these warranties, what's the expected value? And so all we need to do is take each of the values of the random variable and multiply it by the associated probabilities, which are just 2 of those, and that's going to give us that value here. Okay, so we have a series of questions here to choose from, or I said responses, excuse me, to choose from here. And so what I'm going to do, I'm just going to jump in here just to show you this, because it's really a fairly simple explanation here. We essentially have 2 results, right? Okay, and one of them is they're going to pay out this much money, right? Okay, on 8% probability, or they're also going to go ahead and pay out no money, right? If the car, if they don't have to replace it, they don't have to pay anything, and there's a 92% chance of that happening. So using this formula here, they would expect, okay, to make or lose enough money from the warranties here. So they're going to expect to pay $968 out, okay? Well, if they're bringing in 934, and that's where that other dollar figure comes in, and they're paying out this much, they expect to pay this much out on average, then they're going to be losing $34 on each of those warranties. Okay, and this is kind of what they do in terms of determining cost and so forth. And obviously, if that profit margin doesn't have to be that big, okay, obviously you don't want to have it pay so much for the warranty that people aren't going to get it, but you kind of have to dance here on that line. And again, this is just a very practical probability problem in itself. If we sell a lot of these things and make $5 on each of them, then that's a whole other problem that we could go to try to maximize the profit on that. But nonetheless, this is just pretty straightforward here. So it would have been the second answer. Okay, in the long run, they're either going to break even. This is the break even response. this is the money if they're making. So if this were, let's say, 0, okay, then that's going to be a break-even point, or they'd expect nothing to happen. Okay, if they can expect to make money on this, well, if this were a positive 34, then obviously we would have picked this number and again put in a 34 here again. Okay, we're not putting in a negative because we're using the word lose. All right, so there you have it. There, just kind of a pretty big gathering of these. I just wanted to take a look at all of these problems before we'll jump into the binomial next. All right, so there you have it, some ALEKS examples with discrete random variables and expected value and variance.